What if I told you that time travel into the future might not just be science fiction anymore? What if the key to unlocking the mysteries of time has been hidden within the laws of physics all along, waiting to be uncovered by artificial intelligence? Recently, Google AI Studio, an advanced artificial intelligence system designed for cutting-edge scientific research, made a discovery that could challenge everything we thought we knew about time itself. A groundbreaking new AI experiment has revealed a bizarre phenomenon, one that scientists never expected to see. Could this be the first real evidence that jumping forward in time is scientifically possible? Here's the shocking part. The results have already sparked a heated debate among top physicists. Some say this could rewrite the laws of physics, while others warn it could be too dangerous to explore. But before we get into that, ask yourself this. If traveling into the future is possible, what would that mean for humanity? Stick around because what you're about to hear changes everything. If you want to stay ahead of discoveries like this, make sure to subscribe. We break down the biggest breakthroughs in science every week. The science of time travel, from fiction to reality. For decades, the idea of time travel has been confined to science fiction. From H.G. Wells' The Time Machine to blockbuster movies like Interstellar, the concept of moving through time has captivated our imaginations. But what if it was more than just a fantasy? What if the key to traveling into the future had been hidden within the laws of physics all along, waiting to be uncovered by artificial intelligence? Recently, Google AI Studio, an advanced artificial intelligence system designed for cutting-edge scientific research, was tasked with analyzing complex simulations of quantum mechanics and time itself. The goal was to understand the way particles behave at microscopic levels, particularly in relation to time. But what the AI found was something completely unexpected, an anomaly so strange that some scientists believe it could be the first real clue that time travel into the future is possible. At its core, Google's AI was exploring a concept deeply connected to Einstein's theory of relativity, the idea that time isn't constant. Instead, it stretches, bends, and even moves differently depending on speed and gravity. We already know that astronauts aboard the International Space Station experience time dilation, a phenomenon where time moves slightly slower for them than for people on Earth. It's a proven fact that the faster you move, the slower time passes for you relative to someone at rest. But what Google's AI discovered suggests that this effect might not be limited to extreme speeds or gravity fields. The AI's analysis revealed that under specific quantum conditions, subatomic particles appear to shift forward in time at rates beyond what conventional physics predicts. In simple terms, they seem to be moving into the future faster than normal, as if they had somehow bypassed the usual flow of time. If this finding holds up, it could mean that time travel into the future isn't just a theoretical possibility. It could be something that happens naturally at the quantum level. And if it's happening there, the next question is obvious. Could this phenomenon be scaled up to larger objects or even humans? The quantum anomaly, a glimpse into the future. The scientific community is divided on this discovery. Some physicists believe this is just an artifact of the AI's calculations, a mathematical quirk with no real-world implications. Others, however, argue that this discovery aligns with existing time dilation theories, but takes them to a whole new level, one where future time travel could be engineered rather than simply experienced passively. But here's where things get even stranger. The AI didn't just observe this anomaly, it also ran predictions based on these findings. And in doing so, it hinted at something even more profound, a potential method for controlling the rate at which time moves forward. Could this be the beginning of a breakthrough in practical time travel technology? Itzo, zrenia? Or is there something fundamental about time that we still don't understand? The next phase of research is already being planned. But what happens next could determine whether this discovery is just an interesting anomaly or the first step toward unlocking the future itself. Einstein's legacy: time as a flexible fabric. The idea that time might not flow at a constant rate is not new. Scientists have long known that time dilation occurs when objects move at extreme speeds or experience intense gravitational fields. But Google's AI may have found something even more intriguing, a potential loophole in time itself. During its quantum simulations, the AI detected a pattern. Certain particles weren't just experiencing time dilation, they seemed to be accelerating into the future at unpredictable rates. Instead of simply aging slower or faster due to speed or gravity, these particles appeared to momentarily jump forward in time, skipping tiny fractions of normal progression. This isn't how time is supposed to work, according to classical physics. Time should move in a smooth, continuous flow. But Google's AI data suggests that under certain conditions, time may behave in a fragmented or nonlinear way at the quantum level. This discovery has a direct link to Einstein's theory of relativity, which already predicts that time travel into the future is possible under the right circumstances. We know that astronauts orbiting Earth age slightly slower than people on the ground. But what if we could manipulate this effect, control how fast or slow we move through time? Some scientists believe this could be the first real evidence that time travel isn't just a theoretical concept. It's a fundamental property of the universe. Others remain skeptical, warning that we might be misinterpreting the AI's findings. The experiment: how Google's AI uncovered the loophole. So how exactly did Google's AI uncover this potential loophole in time? The answer lies in a highly advanced simulation, one designed to test the limits of quantum mechanics. The experiment began with a simple question: what happens when we manipulate time at the smallest possible scale? To find out, Google's AI ran a complex simulation using quantum particles, infinitesimally small units of matter that follow completely different rules than the physical world we see around us. Scientists already know that quantum particles don't behave in a predictable way. They can exist in multiple places at once, instantly influence each other across vast distances, and even move backward in time under certain conditions. But what the AI found was something completely unexpected. Certain particles didn't just behave randomly, they appeared to skip forward in time. At first, researchers thought this was a simple error in the AI's calculations, but after multiple tests, the results remained the same. The simulation showed that under specific conditions, particles seemed to bypass small segments of time entirely, as if they had momentarily leaped into the future. This discovery was so shocking that the research team ran a separate set of tests to confirm it. The AI then attempted to predict when these time jumps would happen, and to their astonishment, it succeeded. It found patterns, hidden clues buried in quantum mechanics, that suggest time might not flow as smoothly as we once believed. If this anomaly can be replicated in real-world experiments, it could mean that time travel into the future isn't just possible. It's already happening at the quantum level. But what does this mean for us? Could this be the first step toward controlling time itself? Or are we simply scratching the surface of a much bigger mystery? The physics behind the phenomenon. If Google's AI is right, this discovery could challenge everything we thought we knew about time. But how is this even possible? To understand what's happening, we need to break down the physics behind it. At the heart of this phenomenon is quantum superposition and entanglement, two strange effects that allow particles to exist in multiple states at once and influence each other instantly, no matter how far apart they are. But here's where things get really interesting. These same principles might also allow particles to skip forward in time. According to Einstein's theory of relativity, time is not fixed. It stretches and bends based on speed and gravity. We've already proven this with time dilation, where astronauts in orbit age slightly slower than people on Earth. But what Google's AI suggests is something even more extreme, a scenario where time isn't just moving slower or faster. It's actually jumping forward in bursts. One possible explanation lies in the many worlds interpretation of quantum mechanics. This theory suggests that every possible outcome exists in parallel timelines, and what we perceive as time is just our consciousness moving through these possibilities. If that's true, then these quantum jumps might not just be random. They could be evidence that particles are hopping between different versions of the future. Another possibility is that we are witnessing an effect similar to closed time-like curves, a concept in theoretical physics where time loops back on itself. If these loops exist at the quantum level, they might explain how certain particles can momentarily move forward faster than expected. But if this is happening on a small scale, could it be scaled up to larger objects or even people? Some scientists believe it might be possible under the right conditions. Others argue that even if time travel is real, there could be hidden rules that prevent anything larger than a particle from experiencing these jumps. Either way, the implications are enormous. We may have just uncovered the first real clue that time travel into the future isn't just possible. It's already happening at the quantum level. But now we have to ask, what happens when we test this theory on a larger scale? And if we could control these time jumps, would it mean humanity could one day travel into the future? The next step, testing the theory in the real world. If Google's AI has truly found a way for particles to jump forward in time, the next step is clear: testing this in the real world. But how do you take a strange quantum anomaly from a simulation and turn it into a full-scale experiment? Physicists are already discussing ways to replicate this effect in high-energy particle accelerators. These powerful machines, like the Large Hadron Collider, smash particles together at near-light speeds, revealing the hidden laws of the universe. If scientists can recreate the AI's findings, they might be able to observe time jumps in real physical particles, not just in simulations. One proposed method involves trapping quantum particles in an ultra-cold environment and exposing them to extreme magnetic fields. This could mimic the conditions in which the AI detected time jumps. If successful, it would be the first controlled experiment where time dilation occurs in an unpredictable quantum way. But here's where things get even more fascinating. Some researchers believe that if these time jumps are real, they might be happening all around us right now. We simply haven't had the technology to detect them. If that's true, then time travel into the future may already be a natural process happening at the quantum level. And if we can learn to control it, it raises a huge question. Could we one day send larger objects or even humans into the future? It might sound impossible, but remember, just over a century ago, people thought space travel was pure fantasy. The challenges: scaling up quantum time travel. Even if Google's AI is right and time travel into the future is possible at the quantum level, there's one massive problem: scaling it up. Right now, the effect has only been observed in subatomic particles. These particles exist in a strange world where the laws of physics behave differently. But as soon as we move up to larger objects, atoms, molecules, or even a human, quantum effects tend to disappear. This is known as quantum decoherence. In simple terms, quantum particles can exist in multiple states at once, but as soon as they interact with the larger world, they lock into a single reality. If the AI's discovery depends on quantum mechanics, scaling it up may require an environment completely isolated from outside interference. Another major hurdle is energy. Time dilation, as predicted by Einstein, requires extreme conditions, like traveling near the speed of light or being near a massive gravitational field. If these quantum time jumps follow a similar principle, how much energy would be required to scale them up? Right now, we simply don't know. Some scientists also argue that even if quantum time travel is real, It may be limited to information, not physical objects. This would mean that while particles can jump forward in time, humans may never be able to follow. Instead, we might be able to send data into the future, potentially unlocking new ways of predicting events before they happen. But what if we're thinking about it all wrong? What if there's a way around these limits, one hidden in the very fabric of space-time itself? Wormholes, a shortcut. Through time? If scaling up quantum time jumps is nearly impossible, could there be another way to reach the future faster? Some scientists believe that wormholes, theoretical shortcuts through space-time, might provide the answer. Wormholes are a direct prediction of Einstein's general theory of relativity. In theory, they act as tunnels connecting two distant points in space and time. If a stable wormhole could be created, it might allow a traveler to step in at one point in time and emerge at another, potentially far into the future. But here's where things get interesting. Some physicists believe that quantum fluctuations, like the ones Google's AI detected, could actually be the key to stabilizing a wormhole. Normally, a wormhole would collapse too quickly for anything to pass through. But if these quantum time jumps are real, they might be connected to a deeper property of space-time that allows certain regions to stretch time at an unpredictable rate. This means the AI's discovery might not just be about tiny particles. It could be revealing a hidden mechanism in the universe that makes time travel possible on a much larger scale. However, there's a catch. Even if we could open a wormhole, there's no guarantee that it would lead to the future. It could just as easily take us to a different location in space, or worse, collapse before we could enter it. Still, some scientists believe that wormholes could be engineered using exotic matter, hypothetical particles that have negative energy and could keep a wormhole open. If Google's AI has uncovered a real quantum loophole, it might be the first step toward proving that these structures could exist. The ethical dilemma. Should we control time? If quantum particles are already jumping forward in time, the next big question is, can we control this effect, or is it just a random glitch in the universe that we can only observe but never use? So far, the time jumps detected by Google's AI seem to happen under specific conditions. That's a good sign, because it suggests they aren't just random chaos, but instead follow hidden rules. Rules we might be able to understand and manipulate. One possibility is using quantum computers to control time at the smallest possible scale. Unlike regular computers, which process information in a linear way, quantum computers operate using superposition and entanglement, two effects directly related to time manipulation. If scientists can figure out how to trigger controlled time jumps inside a quantum processor, we might be able to send information or even objects into the future at will. Another theory is that gravity plays a key role. If these time jumps are influenced by gravity, then placing quantum particles in extreme gravitational environments, like near a black hole or in a high-energy laboratory, might allow us to amplify and control the effect. But even if we can control these quantum time jumps, that leads to an even bigger ethical and scientific question. Should we? Messing with time at the quantum level might have unintended consequences. Some physicists worry that forcing time jumps could disrupt other fundamental processes in the universe. Others believe it could open the door to paradoxes, where information from the future could influence the present in unpredictable ways. But if time travel into the future is possible, then the real question is, has someone or something already used it? Could it explain some of the strangest anomalies we've observed in physics? And if so, what does that mean for our understanding of reality itself? The future of humanity. A new frontier. If time travel to the future is real, even at the quantum level, how will this change our future? Right now, we're limited by time. We age, civilizations rise and fall, and scientific progress takes centuries. But if Google's AI has uncovered a real way to jump forward in time, we may one day escape these limitations. Imagine a future where astronauts could use controlled time jumps to travel vast distances across space, instead of waiting decades for a journey to another star. What if they could leap forward in time instantly, arriving at their destination without experiencing the long wait? Even more mind-blowing is the idea that entire civilizations could use this technology to skip ahead. If humanity ever faces an extinction-level event, like a supervolcanic eruption or an asteroid impact, we could, in theory, place people into quantum time capsules, allowing them to wake up in a safer future. But this technology wouldn't just be about survival. It could also revolutionize knowledge itself. Right now, scientific discovery is limited by the pace of research. But what if we could send information into the future, allowing scientists to build on discoveries that haven't even happened yet? Of course, there are risks. If time travel is real, would only the most powerful governments and corporations have access to it? Could it create a world where some people can escape time while others are stuck? And then there's the biggest question of all. If this discovery is real, has someone already used it? If time travelers exist, would we even be able to recognize them? Conclusion: is time travel to the future possible? After everything we've uncovered, is time travel to the future actually possible? Based on what Google's AI has discovered, the answer seems to be yes, at least at the quantum level. We now have evidence that particles can jump forward in time under certain conditions. And if this effect can be controlled, it could open the door to technologies that completely change our understanding of time itself. But there's still one major problem: scaling it up. Right now, these time jumps only happen with subatomic particles. Turning that into a system that works for humans, or even larger objects, will require breakthroughs in quantum mechanics, energy manipulation, and possibly even gravity itself. Still, history has shown that once we detect a new scientific effect, it's only a matter of time before we learn to use it. Less than a century ago, quantum mechanics was nothing more than a strange mathematical idea. Today, it powers technologies like transistors, lasers, and quantum computers. Could controlled time travel be next? One thing is clear: this discovery changes everything. If time travel is real, it could explain some of the biggest mysteries in physics, from neutrinos behaving strangely to the possibility of wormholes. It could also raise questions we're not even ready to answer yet. But now we want to hear from you. If time travel to the future is possible, how do you think it will change the world? Let us know in the comments. And if you want to stay updated on groundbreaking discoveries like this, make sure to subscribe.